Good morning and welcome to today's lecture. Today we will discuss some problem regarding finite automata, finite state machine, or especially we will focus on some problem in which more than one conditions are given. I'm just giving an example. Suppose alphabet set is given as A comma B, and there is a language L1. This L1 states that number of A symbols in any word when divided with 2 gives remainder 1. Suppose this is the language. If then we want to write some basic strings of this language. Starting string. Number of A in W when divided with 2 gives remainder 1. That means the minimum number of A in string will be 1. Then the minimum string is A. The next string, 0 length string, is not possible. Epsilon is not possible here. The next 2 length string will be AB, BA, but not BB, because number of A in this string is 0 and 0 is divided by 2, do not give remainder 1. Also, A will not in this language. Why? The number of A occurrence is 2. When it is divided by 2, gives remainder 0. So, I have just given basic first 2 or 3 string of this language. Now, the language is we are quite comfortable in drawing a machine or constructing a machine which will accept all the string of this language. How? Starting with some state, initial state P0, and we will think like this. The coming character, the first symbol may be anything, 0, A or V. Suppose A is arriving. That means the A comes under counting. A पे हमें ध्यान रखना है. Number of A divided by 2 is equals to 1. But when we will in alert mode जब A आएगा, तो suppose first symbol is A. अगर A आया तो we will change the state. Why we are changing the state? Only to memorize this, we have just encountered a simple A. If the first symbol is B and consecutive B, we doesn't care for this. Now, accepting this as a final state in P1. Is it fine? Now, on P1, A may arrive. On P1, when A is arrived, then the condition is violated. Number of A in the string when divided by 2 will not give remainder 1. And for B, we don't bother. This is the finite state machine for the given language. And suppose another language is given also, L2. In L2, number of B in W divided by 2 gives remainder 0. Maintaining the same logic, M0 on B, we will Focus on B symbol. M1. Here the condition is changed. We will focus on number of B when the number of B is even. When divided by 2 gives remainder 0. It means this is the final state. Coming A will not bother us. How many occurrence of A will be there? And just like in this. Now, 0B, we are at final, 1B, we are at non-final, 2B, we are at final, and so on. But suppose in any language, these two conditions are combined. I'm just quoting the statement. Suppose in any language L3, the same alphabet set is there, A and B, and both conditions are combined. Just like number of A in word divided by 2 gives remainder 1, and number of B in word divided by 2 gives remainder 0. In this language, we have combined both the condition. Now the strings will be different. In each string of this language L3, number of A, the occurrence of A when divided by 2 gives remainder 1, and at the same time number of B divided by 2 gives remainder 0. That means the minimum string should be A. Number of A divided by 2 gives remainder 1. Number of B is 0 here in this string. When divided by 2 gives remainder 0. The next epsilon is not possible. The next string should be, is it possible A? No. Is it possible AB? In terms of number of A, it is valid, but we have combined both the condition. Then in terms of B, it is not valid. BA, same also. BB, in terms of B, it is valid, but in terms of A, it is not valid. We must have a minimum occurrence of a single A. ABB, again valid string. Is it fine? Now, for these problem in which more than one conditions are combined with some conjunction like and or, and gives the impression that both these conditions are satisfied simultaneously. Or suppose if or is written here, then in any string either number of A in word divided by 2 gives remainder 1, or either this is satisfied or number of B in word divided by 2 gives remainder 0, or both are satisfied as per the dictionary meaning of or and. So we are taking care of only and here, and we have just constructed the machine of these two part of this language, and these two part are combined here. So now I am introducing some important tool called Cartesian product here. First examine the question. There may be more than one part. Construct each part separately. Here there are two parts. We will construct both the parts separately. For example, this first part. And then the second part. For the first part, just we have constructed the finite state machine. And for the second part, so what we have done? We have constructed the all parts of the given language, given problem separately. It may have 3 parts, it may have 4 parts, then it may have 3 machines, 3 separate machines, the one finite state machine and the other finite state machine. Now, we will write the equivalent set representation of this machine. That means, in this machine, in the first part, there are 2 states, A and B. And in the second part, also there are 2 states, M and N. We will take the Cartesian product of these 2 sets. It will give a set having 4 elements. Will give a set having 4 elements. These 4 elements are stating the states. I will rename it later. Generally, we do not prefer to write 2 symbols state name. It is not a very compulsion, but then later we will change this in a single digit. But first we will construct this. Now, the first element AM, the second element AN, the first element, the third element BM, and the fourth element BN. After taking Cartesian product and the result of Cartesian product having 4 elements, we have constructed 4 states. Now, again, come to the original part. In the first part, A is the initial state. In the second part, M is the initial state. So, in any finite state machine, there is only one single initial state. Final state may be more than one. So, the combination which gives A and M simultaneously is our initial state. A and M. Now, on A, acceptance of a small a symbol, we are reaching at B, and on M, acceptance of a small a symbol, we are reaching at M. That means the combination is BM. On AM, when we accept small a as a symbol, the resultant state is, where we are transmitting is BM for small a. Similarly, on capital A state, on acceptance of small b, we are staying at capital A. On capital M, acceptance of small b, we are moving to N, AN. And similarly, Now we have constructed the final finite statement, but still again we will look to the parts. In first part, B is the final state. In the second part, M is the final state. Means in the first part, B is the final state. In the second part, M is the final state. Now we will move to the question again. We will move to the original language again. Here, and conjunction word is written. That means both conditions are satisfied simultaneously. That means the state which has combination of B and M will be the final state. B and M will be the final state. If or is written here, then the condition will change. Either first part will be true or the second part will be true, or both are true simultaneously. In that case, either B is appearing anywhere, or M is appearing anywhere, or BM is appearing anywhere. In that case, BN will be also a final state, BM is also a final state, and AM will be also a final state. Because here M is there, here B and M both are there, here B is there. I am just quoting one more example. Suppose the language is and the same alphabet A and B. Number of A in W taking modulus with 3 gives remainder 1. Number of B in W taking modulus with 2 gives remainder 0. Is it fine? Now, the language states that all the strings have either number of A in words when taking modulus with 3 gives remainder 1. All the string in word in which number of B in word when divided with 2 gives remainder 0. And both condition having a conjunction of or. Either this is true or that is true or both are true. So following the same logic, we will construct the each part separately. The first one. We will focus on A symbol. And we will not bother about symbol B. Now, first part is stating that when divided with 3, the number gives remainder 1. Now we are at second part. Again, by the same logic, we will take the Cartesian product. The first set is A, B, C, and the second set is M, N. Now the result is AM, BM, CM, AN, BN, and CN. Six states are there. Now first we will decide the initial state. In first part, the initial state is A, and in the second part, the initial state is M. The initial state is M. So, combination of A and M will be the initial state of our combined diagram. Now, we will decide the movement. On acceptance of small a at A, we are moving at B, and on acceptance of small a, we are staying it at M in the second part. That means the combination is BM. Similarly, this one. Similarly, this one. Now we are at a position to decide the final states. In the first part, B is the final state. In the second part, M is the final state. Now we will look into the conjunction word, that is OR. That means both conditions can be satisfied, either one condition or. That means either capital B later is appearing in any state, or capital M later is appearing in any state, or both. Capital B, capital B, capital M, capital M. There is no B, no M, no B, no M. Now the equivalent finite state machine is this one. So, in the similar way, we can combine more than 3 also. Just one more example for your practice also. Suppose there is a language L5 in which the alphabet symbol is and now the language is number of A in a string or word divided by, or taking modulus whatever, divided by 3 gives remainder 2. Number of B in W divided by 2 gives remainder 1. Number of C in W divided by 2 gives remainder 0. Now we will use the conjunctive word like and or. That means in the language L3 there may be any valid string. This valid string contains number of A when divided by 3 gives remainder 2, and number of B when divided by 2 gives remainder 1, or number of C when divided by 2 gives remainder 0. We will construct all the parts separately, taking Cartesian product. It will give how many state? 12 state. And using and or condition, the final state of first part with addend with final state of second part, but odd with final state of third part. Thank you.